Hello, my little mathematicians. Today, I'm going to help you with a cool hack of trying to change repeating decimals to fractions. Okay. Changing a fraction to a decimal isn't that bad because you just take the top divided by the bottom, right? But if you need to go from a decimal to a fraction, that's a little bit trickier. And you guys are pretty good at ones that end, but if they keep going and going and going, they're a little bit tricky. But today, hopefully that won't be the case anymore. Okay, so first off, if you need help, you can use a calculator. But hopefully a lot of you know that when you go 3 divided by 10, you get 0.3. Okay, because this is the decimal and it's in the 10th spot. So there we go. Okay, 7 is your decimal and it's in the 10th spot. There you go. Okay, 131 is the decimal and there should be 3 numbers after the decimal because there's 3 zeros here, or the last number should be in the thousands place. Okay, pretty straightforward. If you didn't know those, you could always just take the top and literally type it into your calculator. 3 divided by 10, look, you get 0.3. 7 divided by 10, you get 0.7. 131 divided by 1,000, and you get 0.131. Okay, so 35 divided by 100, what are we going to get? 0.35. But that only works when you have denominators of 10, 100, or 1,000, right? What if you have a denominator of 9? What do you think is going to happen? Well, let's try it. 7 divided by 9, you get 0.7 repeating for forever. So like 7s with a bunch of dots, or sometimes you'll even see 7 with a line over it. Both of those are saying 7 going on and on and on forever. And you're like, no, it ends with an 8 here in my calculator. Okay, what's actually happening is the calculator just rounded it off because it's like, well, there's another 7, and then that 7 tells this 7 to go up to an 8. But essentially, it keeps going on and on and on until the end of time with 7s. Okay, any idea what this is going to be? Well, let's see. 5 divided by 9, because a fraction is literally saying top divided by the bottom. You get 0.5 going on and on forever. Okay, or again, some people do it like this with dots. Both of those are saying 0.5 repeating. Okay. Now, based upon that, how do you think we would write these decimals as fractions? Okay. If you think you got it right, test it with your calculator. Like test your fraction divided by that to see if you get this. Okay, so pause it, try it yourself, and then unpause it and come back. Okay, so you paused it and you're back with us. Well, hopefully you know that this is 2/10. Okay, so the numerator is the number after, and then the 2 is in the tens place, so there we go. Okay, 45 is in the numerator, and there's 2 numbers after the decimal, so that's the hundredths place, or 2 numbers after the decimal, 2 zeros. 1 number after the decimal, 1 0. Okay, 1 number after the decimal, so 1 0. That 7 is in the tens place, right? So that's the numerator, and then since it's in the tens place, that's my denominator. And then the whole number just stays in front. Okay, and then, of course, that can't reduce, but if it can reduce, reduce it. Well, that can be reduced by 5, so you get 9/20. And this can reduce by 2, so you get 1/5. Okay, then we have these guys. Anyone figure out a pattern, you think? What do you notice the difference between these and these? Well, these ended in powers of 10, and these had a denominator of 9. So the denominator was 9, and the numerator is whatever that was. So let's try 2/9. 2 divided by 9. Look at that, you get 0.2 repeating. So if you put 45 over 9, that doesn't make sense because that's just 5. But what if I added another 9? Just like if that wasn't repeating, if it was just 0.45, wouldn't that be 45 hundredths. But since it's repeating, I'm putting it not over 45 hundredths, but 45 over 99. Just like this is 2 tenths, this is 2 ninths. See, it's one less than that. This is 99 is one less than 100. So this would be, the whole number is still 3, but 7 over a 9. Okay, we'll test that. 7 divided by 9, yep, is the 0.7 repeating, and then plus 3, hey, look at that, you get 3.7 repeating. Okay, here, try 45 divided by 99, and you get 0.45, 45, 45, 45, 45, forever and ever and ever. Okay, perfect. The only thing is, could I have reduced this? Yeah, 9 could have gone into both of these, and then you would have gotten 5/11ths. But the hard part was knowing how it started. Okay, so is there a rule that you think you can say? Yeah, what? What do you think that rule is? Okay. So if you flip it over, terminating decimals, so that's ones that end, like here and here and here and here. Okay, they don't keep going on and on forever. The numerator is the numbers after the decimal. So 5 is after the decimal, that's the numerator. 4 is after the decimal, so that's the numerator. 12 is after the decimal, so that's the numerator. 45 is after the decimal, so that's the numerator. And then the denominator is the decimal's place value. The decimal's in the tens place, the decimal's in the tens place, the 1 is just a whole number. The last number is in the hundredths place, or there's 2 numbers after the decimal, so 2 zeros. Same thing here, 2 numbers after the decimal, so 2 zeros, or the 5 is in the hundredths place. And then don't forget that whole number in front. Okay? And then if you can reduce, don't forget to reduce. So that can be divided by 5, so you get 1/2. This can be reduced by 2, so you get 1 2/5. This can be reduced by 4, or 2 times. So you get 3/25. And then this can be reduced by 5. So you get 3 9/20. Okay. Now we have all of these repeating ones. So remember, hopefully you saw that if it's a repeating decimal, the repeating numbers, the ones after the decimal, are the numerator. So the numerator will be a 3, a 57, a 15, because look, it's like the 1 5 1 5 1 5. Whole number is 12. 63 is my numerator, whole number 7. 6 is my numerator, whole number 5. 7, 8, and 9 is my numerator. 2 is my numerator for whole number. And 5 is my numerator. Okay, the denominator is a 9, but like however many 9s there are. Just like however many numbers after the decimal there were, that's how many zeros there were. So 1 number after the decimal, 1 0. 2 numbers after the decimal, so 2 zeros. If there was 3 numbers after the decimal, there'd be 3 zeros. That same rule applies, but with 9s. So 1 repeating number, so 1 9. 2 repeating numbers, so 2 9s. 2 repeating numbers, so 2 9s. 2 repeating numbers, so 2 9s. 1 repeating number, 1 9. 3 repeating numbers, so 3 9s. And 1 repeating number, 1 9. 1 repeating number, so 1 9. Okay, test that. 3 divided by 9, yep, 0.3 repeating. 5 divided by 9, 0.5 repeating. 57 divided by 99, okay, that's 0.57 repeating in my calculator. For the next one, it says 2 divided by 9, that's 0.2 repeating, plus the 4 would be 4.2 repeating. Okay, 15 divided by 99 gives me that 0.1515. And 789 divided by 999 is 0.789 repeating. And 63 divided by 99 is the 0.636363. And finally, 6 divided by 9 is the 0.6 repeating. Okay, so I think it's safe to say that that rule will always work. The last thing is just don't forget if you can reduce. So this can reduce by 3, for 1/3. Let's see. Can 9 go into that? No, but 3 can, because 5 plus 7 is 12. And since 3 can go into 12, 3 can go into 57. And 3 can go into 99 33 times. Let's see. 57 divided by 3 is 19. Okay, I know that 3 can go into both 5 and 33 times, fully reduced. 9 can go into both of those. So that's 7 and 11, fully reduced. 3 can go into both of those. You get 2/3. And I know 3 can go in. So that would be 3, 3, 3. And 7, 8, 9 divided by 3 is 263. They're not even. 9, 10, 11. 3 can't go into 11, so 3 can't go into that. I'm going to say that's fully reduced. That's fully reduced. And that's fully reduced. And there you go. Yeah, the reducing part can be a little bit tricky. Once you guys are allowed to use fancy calculators later to see if it's fully reduced, like let's test it with this one. Once you know the hard fraction of 789 over 999, hit equals and it'll tell you what it is fully reduced. Nifty trick, right? But until then, we do need to be comfortable with our divisibility rules. Like 5 can go into something if it ends in 5 or 0. 2 can go into something if it's even. 10 can go into something that ends in 0. And 3 is if the sum of the digits is divisible by 3, 3 can go into that number. It's like 5 plus 7 is 12. 3 can go into 12, so 3 can go into that number. So then you go 3 into 57 and figure out it's 19. So knowing your divisibility rules is very helpful. And then later, once you get into advanced math, then you can use the fancy calculators and you can have it help you reduce. Okay. Now, pretty much to me, that's all you need to know is remember these little rules up here. If it's after the decimal, that's your numerator, whether it's repeating or not. And however many numbers there are after the decimal for terminating ones, that's how many zeros there are. So that's the place value. And if it's a repeating decimal, however many numbers are after the decimal repeating, that's how many nines there are in the denominator. Okay, now for those that are curious of why this works, here you go. Let's say, for instance, you had like 0.3 repeating, right? Okay, 0.3 repeating we know should be 3 over 9. Now let's see why that is. Let's say that x is 0.3 repeating, okay? So let that be x. Well, let's multiply both of those sides by 10. You can do whatever you want as long as you do the same thing to both sides, right? Well, 10 times x is 10x. And if you multiply 10 times 0.3 repeating, that essentially just moves the decimal over 1. So now you have 3.3 repeating. Okay, so I'm to this step. Let's try subtracting x, because if I subtract x from both sides, x is equal to 0.3 repeating, right? So if I subtract 0.3 repeating from this side, these cancel, and I'm just left with only the 3. And then over here, I don't want to cancel out like 0.3 repeating, but 0.3 repeating is equal to an x, so let's subtract an x on this side. And I can do that because essentially an x is the same thing as a 0.3 repeating, right? So on this side, I did 0.3 repeating, and I got just 3 left because these canceled each other out. And then on this side, I'm canceling 0.3 repeating as well, but in the terms of an x. And 10x minus 1x is 9x's. So now you're right here. 9x equals 3. Now, if you want to solve for like what is x, how do you get x by itself? We'll divide both sides by 9. You can do that as long as you do the same thing to both sides. 9 divided by 9 is 1, so you have 1x. And on this side, 3 divided by 9 is 3/9. So look at that. X is 3 over 9 when you're talking about like 0.3 repeating. And then, of course, you would reduce that, and you get 1/3. If you caught that, awesome. If you didn't, don't worry about it. It's just for those that are curious of like, why does this trick work? There you go. There's the math behind it. If you want to test it for other repeating decimals, it'll use that same type of logic. But the main thing is, remember the rules up here to help you figure this out. And then that should help you in the long run whenever you're trying to deal with repeating decimals.